How to fabricate bridges with zirconia frames. We will now demonstrate how to fabricate a bridge composed of a zirconia frame to completion. We will start with the editing of the mesh, but we will proceed as if the editing of the crown outline has already been completed. 1. Edit the mesh. 2. Convert the mesh to a surface. 3. Creation of frame outline. 4. Add reinforcement to the frame. 5. Creation of pontic portion. 6. Creation and consolidation of the collar portion of the bridge. 7. Connect the main frame and lingual collar portion. 8. Fabrication of bridges for the entire dentition. The following explanation is divided into 8 parts. This example will be illustrated using SolidWorks. 1. Edit the mesh. Demonstration of zirconia ceramic frame creation from mesh editing to complete bridge. This is the mesh after scanning. There are spike-like errors in the mesh. I used the Mesh Wizard in SolidWorks to remove errors that were causing the mesh to spike. The scanner used, MDX15, by Roland, has a unique scanning method, so the mesh of the face near the vertical plane is a vertical triangular shape. This is why the mesh cannot be edited properly in SolidWorks. We then re-edited the mesh using mesh editing software, Geomagic Design X64. After re-editing the mesh, all meshes are now of the same size and easier to use. An optical scanner will ensure that the meshes will not be unevenly sized. The scanner, MDX15, by Roland, is no longer available. The Mesh Wizard was used to divide the abutment tooth portion. Since this video is a demonstration, unnecessary parts have been left in place, but it takes a lot of time and effort. In an actual clinical case, it would be acceptable to remove them. The color-coded mesh of the abutment teeth is automatically color-coded when using the Surface Wizard's surface identification function. When using this function, the lever should be set to max on the right side. Trim the abutment tooth portion of the mesh along the margin using the Mesh Wizard. The mesh of each abutment tooth portion is divided into 3 parts: the shoulder portion, the axial surface portion, and the occlusal surface portion. To divide, start with Create Surface Wizard Guidance. You can divide the mesh by color coding. The mesh is divided into 3 parts and made into an offset surface. However, the shoulder portion is left as they are. In this case, the axial surface portion is offset by 0.05 mm and the occlusal surface portion is offset by 0.1 mm. This is done with the Mesh Edit command. This value can be set freely. The 3 edited meshes are made into a single mesh with the Merge command for each abutment tooth. About deviation analysis. Invokes the Deviation Analysis command. It examines the deviation between the mesh before editing and the edited and merged mesh. The meshes to be compared are Mesh 5 and Mesh 40. As you can see in the video, there is no gap in the shoulder area that was not offset during editing. It fits into the mesh before editing. This is the yellow and green area. The axial surface portion was offset by 0.05 mm. An equivalent space was created. The occlusal surface portion was offset by 0.1 mm. The figure is roughly blue, which is about 0.1 mm. The results were as planned, but the values could have been a little larger. When cementing into the oral cavity, if you don't create a cement space, it can cause lifting. 2. Convert the mesh to a surface. There is more than one way to produce a product using general-purpose CAD. There are other possible methods besides the one presented here. The method introduced here is just one of them. The second molar on the left side of the maxilla is presented in this article. Basically, the process is the same whether you are making molars, premolars, or anterior teeth. Displays the mesh after merging the 3 split meshes. Launch the Surface Wizard. Create a surface with the default settings. This red-colored face is an illegal surface. I changed the angle of view. This red face group is a rogue surface. I checked the box here to display the feature line. The orange line is the feature line, and it will be used as a guide when the surface is created. I used these commands to edit and modify feature lines. Also, an unauthorized surface has been created here. Edited the feature line again. Increased the number of streamlines to make them easier to become streamlines. Streamlines are a guide to make object shapes and tissue structures streamlined. This is a top view. Click OK, and the conversion to surface is complete. Create rough, fitted margin lines on the margins. Launch the Curve Wizard. Create margin lines using the merged mesh from earlier. The slide lever position is used as default. Do not move the slide lever from the initially set position. Margin lines have been created. Only margin lines are shown. The margin lines created do not fit the surface margins. This is a deliberate loose fit. A loose fitting line is needed to create a zirconia frame. The position of the slide lever will fit the purpose of the line to be created by default. Slide the slide lever to the left or right to adjust the level of fit. 3. Creation of frame outline. All abutment tooth meshes were offset by the amount of cement space and converted to surfaces. Demonstration of frame outline creation with an upper left second molar. There are anterior teeth, premolars, and molars, but they can be created using basically the same method of operation. Makes surfaces semi-transparent. Make a surface selected and highlight it. This command imports the reference mesh. This is a unique way to operate with a plugin called Power Surfacing. Power Surfacing is a SolidWorks plugin, not a SolidWorks feature. Thanks to this plugin, you can now use SolidWorks to manipulate dental work. Power surfacing is an application that handles subdivision surfaces. The surfaces are created on this reference mesh. Use the Draw Edges command to draw a rectangle on the reference mesh. Once a rectangle has been drawn, you can draw a series of similar rectangles by using the Paint Faces command to stretch them out. After encircling the reference mesh with a rectangle, adjust the size of the rectangle. Select a series of edges as shown in the image and use the Smart Fill command to fill the top with a rectangular face. This is much easier than manually manipulating the image. Select all the created faces and fit them to the reference mesh with Shrink Wrap. Select the Bake into Offset mode to offset the created surfaces. Create an offset 0.6 mm outward with Normal Push. Delete the surfaces created on the reference mesh as they are not needed. This image is viewed from above. Adjust the outer edges of the frame so that they are not extremely outward. After adjusting the position of the margins of the frame outline, select the margin line and pull the margin downwards. Once you exit the power surfacing mode, return to SolidWorks and create the tooth axis. The tooth axis is created with the 3D sketch function. A point is hit on the top surface of the outline and a tooth axis line is created there. Create a fill surface using the first loose-fitting line you created. Move this fill surface upward along the tooth axis by 0.2 mm. The light yellow image is a preview after the move. Moved fill surfaces. Extend the moved fill surface by 0.05 mm. The light yellow color is the preview after execution. Extended fill surfaces. Creates lines on the edges of the inner surface of the frame and the edges of the moved fill surface. Create lines on the edges of the inner surface of the frame with fit spline. Create lines on the edges of the moved fill surface with transform entity. Create a plane that is orthogonal to the line created at the edge of the moved fill surface. Displays the outer surface of the frame. Draw a sketch on the flat surface. This sketch creates the top surface of the frame flare. Create sweep surfaces with sketches and ring-shaped 3D sketches. Create a boundary surface made up of fill surface edges and fitted splines. Perform trimming with the trim surfaces command. Use the frame and flare sweep surfaces. The settings are as shown in the left column. Unnecessary portions have been trimmed. The remaining portions have been merged. Fillets were done. A larger radius fillet could be applied, but considering later operations, we made it large enough that the lines do not overlap. We will knit the surfaces we have created so far. You now have the basic shape of a zirconia frame. After this, there is work to add reinforcements and lingual side collars to the basic shape of the frame. To make it into a bridge, it must be connected. In addition, there is the fabrication of the pontic. You have seen the basic fabrication method for the frame of the left maxillary second molar. The basic frame is made in a similar way for all the abutment teeth. The image shown is the end of the operation. The model tree on the left shows the history of many fabrications. To remove the fabrication history, output the file with the X_T extension. The X_T extension is also the native format of Parasolid, the kernel of SolidWorks, so the conversion speed is fast and error-free. 4. Add reinforcement to the frame. We will now create the reinforcing section of the frame. The method presented assumes that the pre-edited tooth shape has been created on a subdivision surface. Editing the crown shape is done by moving the operation point or dividing the surface. We will not show you how to do this here. The reinforcement section of the frame is created. The reinforcing section is created from the crown form. The crown shape is created in advance and saved as an obj file. Set the mode to power surfacing and load the crown shape. In power surfacing mode, a file cannot be loaded without first having a single object. So, we create a sphere shape for now and load the crown shape. Immediately after that, we delete the sphere shape. Set the mode to select a face by simply tracing it with the cursor. The goal is to make the smaller divided surfaces of the occlusal plane as large as the lateral surfaces. Select and quantize only the smaller divided surfaces of the occlusal plane. The quantize is complete. Next, we will create a 1 mm offset face on the inside, using the normal push command. The original face will remain when we do the normal push, and we can delete it later. Delete the original surface. The offset faces appear to be missing, but this is because they overlap. The Flip Selected Faces command flips the normals of the offset faces. Return from Power Surfacing mode to SolidWorks mode. The Intersection command adds the created reinforcement to the base of the frame. Click on the Intersect command in the list of commands on the right. Select the frame of the body and the addition, which will be highlighted yellow. Any unwanted areas on the inner surface of the main frame are excluded by clicking on them. Click OK to execute the command and add the reinforcement to the main frame. Hide the surfaces you have created to add. Your work is now complete. Let's look at the cross-section of the sagittal plane. To help you understand what we have worked with, we have also shown the outline of the crown. You can see the role of the reinforcement. The uniform thickness of the porcelain material used for the exterior can facilitate and strengthen the buildup. Let's look at the cross-section of the frontal plane. The thickness of the exterior is uniformly secured. Anatomically formed crowns can be used to fabricate reinforcements. 5. Creation of pontic portion. The pontic portions are the left and right central incisors, the left second premolar and first molar, and the right first and second premolars. Use power surfacing. As shown when the basic frame was created, the mucosa surface is loaded as a reference mesh and a surface is created on top of it. Next, we create the offset surface. The specific method was shown when the frame was created, so it will be omitted. Edit the teeth shown in the image. Create a 1 mm offset surface. Delete the original surface. Display results. The normal of the face is inverted, so the color of the face is matte. The face at the incisal edge has been slightly folded over. I believe the reason for this is that the 1 mm offset surface was applied forcibly to the crowded area. Therefore, the command relax is used to eliminate the wrinkles. The level is 300. Wrinkles were eliminated. There appears to be some wrinkling on the basal surface of the pontic portion. Select a larger area around the basal surface. Apply relax to the basal surface. The level is 100. Inverts the normals of a subdivision surface. Smoothly correct the edges. Edit the other side in the same way. Displays the offset surface of the first mucosal surface created. Intersect the edited pontic portion with the offset surface of the previously created mucous membrane surface. Cut the excess and apply a 0.5 mm fillet to the edge created during the cut. The fabrication of the zirconia frame and pontic is now complete. This includes the reinforcement part of the frame section. The next operation is the fabrication of the lingual collar portion and the connection of the frame and pontic. 6. Creation and consolidation of the collar portion of the bridge. An example of a bridge consisting of 5 teeth: upper right canine, first premolar, second premolar, first molar, and second molar, is shown through the final process. We will now explain how to create the lingual collar portion of the bridge. Since explaining a bridge with a long span would take a long time due to the many processes involved, we have decided to explain the creation of a short bridge. Even with a bridge with a long span, there are only more parts to be manipulated. An upper left second molar shows how to make a lingual collar portion. Mode of power surfacing creates the basic shape of the lingual collar portion. Loads the finished tooth, the outline of the crown. The occlusal surface area is not needed and should be removed. Only the lower part of the crown girth is used. This shape is suitable for making a lingual collar portion. Next, a flat surface is stretched over the area of the removed occlusal surface. The border between the axial and occlusal surfaces of the girth is hard-edged to make the boundary clear. The basic shape of the lingual collar portion has been created. The connection of the upper right first molar and second molar. The following shows how to connect the lingual collar portion. Create a separate lingual collar portion for each abutment tooth. The adjacent parts of 2 adjacent lingual collar portions are hollowed out. Select the edge of the hollowed hole. With the edge of the hollowed hole selected, apply the command, bridge. Set one edge in the middle of the connected area and click OK. Pontic first and second premolars are shown translucent. Bridge the right maxillary canine and first molar. Hold down the Control key and select the loop on the adjacent edge. After selecting the loop of 2 edges, right-click to bring up the bridge command and execute it. The number of segments should be 6. A bridge is created between the canine and the first molar. Next, a finishing line is created by making the edges hard-edged to accentuate the border. Next, edit the bridge lines and points so that the transition to the pontic is smooth. I edited the bridge portion. I highlighted the finishing line, so that the ceramic material to be built up and the zirconia frame can be functionally distinguished. The middle portion of the first and second bicuspids is swollen. The reason for this is to ensure the strength of the bridge. I edited the connected parts. After this, we will combine the pontic and bridge. 7. Connect the main frame and lingual collar portion. Connect the lingual collar portion to the main frame. Preparation is required before that. Extract the surfaces of the rising edges near the margins of the frame with an offset of 0 mm. Do this on the upper right canine, first molar, and second molar, respectively. Enters edit mode for subdivision surfaces. Performs fitting of the margin area of the lingual collar portion. Specify a surface extracted from the margin of the frame as a reference surface. There are 4 extracted surfaces. While holding down the Control key, select the 4 ring edges of the lingual collar portion. After selecting 4 edges, click to Edge in the referencing tool. Doing so will cause the ringed edges of the lingual collar portion to match the edges of the extracted surfaces. We are back in SolidWorks mode. Close up the area that matches the edge of the extracted surface. Create a fill surface directly at the edge of the lingual collar portion. The body of the lingual collar portion and the fill surface are combined to form a solid. Create a plane parallel to the dentition. Make a sketch on a plane surface. This sketch is used to cut the buccal half of the lingual collar portion. Extrude the sketch to penetrate the lingual collar portion. Create a continuous surface for cutting the unwanted portion. Remove the buccal half of the lingual collar portion with a surface cut. Rounding with fillets. This one is also rounded with a fillet. The pontic and lingual collar portion are integrated in a combine. Apply a combine with the lingual collar portion and the frame portion. The lingual collar portion is now complete. The frame was used to create the lingual collar portion. Therefore, a new frame was reloaded. The completed lingual collar and frame are combined to form a single unit. The frame of the bridge is now complete. I hope you now have a rough idea of how to make a bridge. After this, I will briefly show you how to make a full bridge for the upper jaw. In clinical practice, I do not believe there are any full bridges with zirconia frames. The catalog states that bridges that can be made with zirconia material are limited to bridges up to 6 span lengths. If you want to make a full bridge, you would use a key and keyway. We did not demonstrate this here. General purpose CAD like SolidWorks is good at making machine parts like keys and keyways, so they are easy to make. 8. Fabrication of bridges for the entire dentition. This is part of a bridge that spans the entire dentition. The same operation is performed for a bridge that spans the entire dentition, only there are more parts to be manipulated. Please imagine the whole picture. The lingual collar portion of the bridge spanning the entire dentition was made. The lingual collar portion of the bridge spanning the entire dentition was made. I gouged out the portion of the buccal frame adjacent to the pontic. When cutting the buccal half of the lingual collar portion, this portion gets in the way and prevents a clean finish. Subdivision surface mode. The surface was subdivided and detail edited as a final finishing touch. A handling knob was added and finally the tips of the margins were matched. A fill surface was created at the tip of the lingual collar portion to solidify the frame. The combine command hollowed out the interior of the lingual collar portion. Create planes and make sketches. Extrude the lines of the sketch to create the basic surface for the cut. The basic surface to cut the buccal half of the lingual collar portion is loaded into the subdivision surface mode to create the surface and deform it to obtain the desired cut surface. The buccal half of the lingual collar portion was cut. Add pontic to the frame, apply fillets, and you are done. The bridge over the entire dentition is complete. The crown is shown superimposed over the frame of the bridge. Only frames of completed bridges are displayed. Unlike dental CAD, general-purpose CAD cannot be edited with a single click. Therefore, the operation method is completely different from that of a dental CAD system. Each step must be followed step by step. General-purpose CAD offers a high degree of freedom in editing, allowing detailed design specifications to be changed and variations to be made freely depending on the situation. This is widely practiced in the general manufacturing industry.